How you doing, people? Got some exciting stuff to share with you guys. A lot of you guys want to know what the numbers really mean. Not, I see one of you guys in the comments made a brilliant comment. I was like, I know how to get the numbers, but how do I know how it affects the saw? You know, what am I looking for? All right, I'm going to lightly touch this subject. We will, in a 372 build, is what I want to do this in. It's the most common saw out there for people, and it shares so much with many other saws. So it's broad. It's a broad-based saw. Bill Block, how you doing? Margaret, nice talking to you the other day. Okay. Now, as you know, for those of you that asked, we alter the timing in the saws. Intake and exhaust, and in some cases the transfer. I'm leery about altering transfer timing, honestly. There's reasons for that. I do it to correct numbers sometimes. A lot of this information was going to be covered in more detail, teaching Cullen how to port and how to get his numbers and what he's trying to get the saw to do. That's where the most information is going to be. But I'll lightly cover the subject because you guys want to know. A 70cc saw, like a Husqvarna 372, shares the same numbers as a lot of other saws. Exhaust blowdown, where it starts, first ray light, we covered that. We'll do all this on video, but let's say that you already know how to get your blowdown, you get your numbers, you know what your timing is, you got your degree wheel running. And you find out traditionally, like a 372 or many other saws, are 104 or 140 or 104 or 105 degrees after top dead center. AT, yeah, you got the rest. And DC. That's common. That's a conservative number. The one thing, there's two things that come into play on this. I'm glad you guys are asking these questions. I have a personal rule, it's not wrote in stone, not to exceed 100 or 160 degrees of rotation on these saws of exhaust opening. Also intake opening. Intake opening on the saws is measured from where the piston starts to rise and the intake starts open with a 50 thousandths feeler gauge. Flow starts and stops at 50 thousandths. Okay? Now that's my opinion, but it's well backed up by motormen. So I use that as a rule. Should I cut my intake back to 152, something like that? Yeah, that's a good idea. If you get your intake duration open too far for too long, you get a backflush through your carburetor. That's one cause of it. But so I'm not pushing intakes very often. I don't go to 160. You see a lot of mine at 150, 152. That's what you see. On my exhaust, I like a balance of power in the form of torque and RPMs. Okay, what I'm doing is raising the horsepower in the cut. That's what I want to do. Now, if you go with too low of a number, let's say 90, on your exhaust, you're going to have the revinous freaking saw you ever seen. That's what makes RPMs. Low blowdown number, where blowdown starts. Okay, so when that exhaust opens too early, the saw will rev like crazy. But you've bled enough compression off and you don't have a long enough power stroke anymore, that you've lost torque. There's a happy medium in that. Factory saws at 104, 105. Lower RPM in the cut, but they go ahead and really pull. I like to see the increased RPMs in the cut. Now, we're talking logging saws you use every day, firewood and stuff, okay? We're going to get into some of the exotic stuff in just a minute. because we are doing some now. I hope that answers your question, guys, on what numbers do I choose. Okay, do you want to know what Iron Horse uses on a 372 or a 44, 46 steel or anything comparable in them? A bigger saw has more torque but less RPMs. Let's say a 66 Magnum 394. Okay, you can push them numbers another 3-4 degrees further if you want to, especially if you got crap loads of compression. As long as you can maintain good compression, you can push them. Smaller saws, if it's at 105 and you got a 45cc saw, leave it, because you don't have enough ass to frickin' make it run any harder anyways. I'll just put it the way it is. Okay? Hopefully that helps you. We will be doing the using the degree wheel. We're going to teach Cullen how to do it. He has to learn that before he can get numbers for a saw. And we're going to take a saw, decide what he wants to do. It's not going to be one of yours. One of my personal saws we're going to do this with.
Oh, boy.
And so if he screws it up, nah, he won't screw it up. He'll do good. No, the first time out, you're not going to do your perfect job. You're going to learn what bad things happen. Okay. I think it was June 23rd that we started doing this saw stuff on video.
Yep.
Yeah. Oh, yeah, it's been a crazy year, ain't it? Hasn't it been crazy? Over 12,000 subs. I love it. You already know that I built saws for Buckin Billy and his son Hogan. We finished Hogan's saw, by the way, and we run that. I'm not going to show it on my videos. I'm just telling you, not going to do it. He's going to have it in his hands directly. You're going to see it first there. Am I happy?
Is Hogan happy already? No.
I sent him personal videos, but it's not over the top. It's a work saw. It's not over the top. It's enhanced. Is what it is. It's kind of neat. And that way cool Buckin Billy freaking crazy design muffler that we did for him. We're gonna build a second one, put it in the box for a 372. Give them two something to freaking get a chuckle out of.
Fight over?
I don't think they'll fight over it. They get along good. Okay, but because of that, when Buckin and I first started doing this, he wanted some crazy, insane saws, and we've built some that run pretty good. Them Pioneers run good. Them 371s run good. You know, his 266. There's Mac I built him. It runs pretty good. I'm a little leery of Mac still. I don't have a full grasp of Mac set, guys. I'm sorry, that's the way it is. Never had to work on many of them. But you can blow them up on the bench. I can tell you that right now.
Yep.
We start pushing RPMs out of them too much.
Checking the box.
Yeah, checking the box.
That one's done. We did it.
Already did it. Hey, you think I don't make mistakes? I do. It's not mistakes. It's calculated risk. We try to eliminate mistakes. But through a little conversation with Buckin, and you've seen it on his channel and mine, we're past that 1 year mark.
Year 2.
I could not afford to have a saw blow up in his hands that came from me for 1 year. You know why. I had to develop credibility. It was hard to do this, to get good power that he was happy with and comfortable with. We've had runability issues and one thing or the other. As you build performance, you can build into performance hard starting, hard to adjust, this or that, little things like that. That's why the factory don't use the numbers we use. I'll tell you that right away. They'd pull their hair out. So, he said it, I've said it, and I'm going to say it again. Buckin's going to get some saws. Serious stuff. No joke, guys. I'm going to tell you right now some of the two-stroke theory. Now, you know that there has been a lot of advancements made in two strokes over the last 50 years. I intend on doing things that hasn't been done. We're going to share every step of the way, successes, failures, and like Well, that was a lot of work and it didn't do anything. We're going to share it. We're going to find out what works. You want to see what some of the stuff I'm going to do?
Year 2 stuff.
Yeah, you're going to see. I'll tell you right now. Okay, the first thing you need to understand is how these work. Your engine fires, piston clears, the exhaust exits, draws some fuel and air mixture that's coming up the transfers out with it. And as soon as there's less pressure in the above the piston, there is an exhaust got more pressure, there's a bounce back. So that raw air fuel mixture gets traveled like a wave, and part of it comes back in. We would like more of that to come back in, but most importantly, we don't want to risk getting exhaust gases expended already back in. So let's correct some of the mechanical problems first. Okay, when you start developing horsepower out of saws, you're limited to what your crank and bearings can handle, and you're limited to what this little guy can do. He's really cooking. Okay, now the one thing you need to know is right here on the intake side, you get a lot of pressure on each side of that intake. And right down here along the circle, you can see the shading. See that? A lot of pressure. See that exhaust side? It doesn't show it. Yeah, I'm going to explain them marks in a minute. Okay. This is time to roll this camera down and get right into this. This might be long. It might be 2 parts. I don't know. I'll see if I can get this pinched out just a bit. Can't do it in front camera mode. We don't care. We don't need it. Okay. What causes that piston skirt to rock and put so much pressure on the intake side is the fact that when this rod, it fires, it goes down, rotates around, the rod changes direction. It's coming at a weird angle up. I mean, like that, see? Okay, right there, as it's coming up, forces that skirt like this hard into the intake. Now, we're going to be chasing on these saws that we're building now for bucking every ounce of horsepower that we can get easily. We're not going to kill ourselves with this. We're not going to do it.
No machining required.
Yeah, there's not. Well, there might be a
minimal,
little,
maybe.
Well, there might be a little machining involved. But so how can I get rid of that? Well, I'm gonna tell you what. It's easier than you think, and it also helps on the exhaust side. I'm gonna take this cylinder. It is in direct, absolutely center of the crank. See the crank there? And I'm gonna exaggerate this. I'm gonna move that cylinder back. Okay. Toward the carburetor more. That gives me more room for exhaust anyway, right? That's good. We're going to have a little confinement problem here probably. We'll solve all of them one step at a time. By moving that cylinder backwards, I am changing the true angle, the effect of the rod being at that angle. And it's going to move the piston back with it, and it's going to want to become straight going up and down in the cylinder. Okay, another thing I'm going to show you. I will not. Anything I know, I'll share with you. I don't think about it. These pistons, after they've been run a while, all of you saw builders probably notice them sharp edges they get right there. They actually get them all the way around, but boy, right there on these on the exhaust side especially, boy, that gets sharp. It really does. You can see that one's kind of rolled. Okay. You can put that in a lathe, and you can turn that down 20 thousandths, 30 thousandths, 40 thousandths from the ring to the top of the piston. Get rid of that friction of this cocking around, okay? That's what you can do, and we're going to be doing that. Okay, we want to get rid of friction. We're getting rid of heat when we get rid of friction, guys. Think about it. Okay, now one of the things that needs to be done. When that piston goes down, it builds pressure in the crankcase. Okay? That forces the air. This is the bottom of the transfers, truly. Here's the transfers finished. Okay? So, in this area right here, you'll see here on the side, air is forced upwards because the piston is going down, and it is truly under pressure and up the transfers. Can we increase that? Oh, yeah. Remember, you've seen it here first. I'm sure that once I proof this, if it works, we're doing if it works on all this. This is what ifs.
Theory.
Now, we know about forced induction. I worked with a lot of it in the past. Superchargers, turbochargers. What if we build a supercharger of sorts right in this crankshaft?
Everything's already there that you need.
It's already
there.
It's already, but it has to be timed because this is a two-stroke.
Yep.
It's got to be timed. Okay. So as this rod piston is going back up, comes around, engine fires, goes back down, opens the transfers right there. See the throws of that crank? All the way to bottom's dead center. Okay, that's the whole time that's forcing air up them transfers. Now, I'll tell you one thing. You notice that great big hole right there where that rod is? That air doesn't go up them transfers, does it? It wheels around in there and sooner or later has to do something. Now, what if we cut channels in this crank that picks this air up? They're going to have to be at an angle like that. And now this is just rough, crude kindergarten drawing. This isn't how it's going to be. Okay, and when that crank comes up, there's where them transfers open. I'm going to shove massive amounts of air for the whole, whatever the timing is, until the transfers close on here. Everything is timed. Okay, during that period, I am going to shove a lot of air fuel up them transfers until that closes.
Not only does the shaping of that do it, the clearance between the walls and the crank and everything will actually help that process even a lot faster yet.
That's how a supercharger works. This is just happens to be a timed supercharger.
Low clearance.
That's right. It's the low clearance. You guys have noticed these cranks
There ain't much room.
are real
Yep.
close. That's what's going to make this work.
Yep.
Just like the clearances in a supercharger are very close.
It's a pump.
That's going to bump. Okay, we need to enhance that. Okay, so we're shoving air. Let's get a little more out of it.
Yeah, what do we do with it now that we got it?
Okay. Now, what if we know we have a pressure pulse? Most saws are 175 pounds, whatever that pressure is that comes out of there has power, plain and simple. I'm going to try to do this. What if right there on my pointer, right there, we bore, let's say 1/4 inch hole on each side. On each side of this. Now what that's going to do is we're going to put a tube coming from about right in here around into our pipe. We're going to do that left and right. That's going to evacuate. When you have that tube at an angle to that exhaust, that works like a siphon. Okay? That's going to pull the gases out of these areas right here and here that I know stay in there. I want to suck that right out. Most importantly, now we've gave a highly pressurized transfer. It is also, when them transfers are open, it's going to have an effect of creating a little higher vacuum, but most importantly, getting rid of more unspent gases and help suck air up them transfers.
It's a Venturi effect.
It's a Venturi effect. So I'm not just shoving air, I am pulling and shoving air. Okay? This is all timed. It has very specific degrees. These things have to happen in volumes. Okay? The volume of your cylinder to where this happens, whatever that calculates as, and however big you're around your tube and however long that is, that volume has to match, and it's going to be right there is where that is.
Also, the direction that you're forcing that air to come in through there, theoretically, dead center is the best way. But if you got two of them coming in at angles, and as long as they don't hit the wall and bounce around the wall, you got it then too.
But yeah, that's right. But it can't come in straight. It's got to come in at an angle, so that pressure going by the hole has a vacuum impulse.
It shears the air, pulls the other air out with it.
Exactly.
At a much faster rate.
Now, in dirt bikes, a lot of you are aware of, you can look this up and see, but like with the KTMs and other ones, you can buy a head that has an insert for the combustion chamber. It just screws right in. Where the spark plug hole is, it just screws right in. And you can change the shape, how much volume, so how much compression you got, and tailor how this engine runs by reshaping your combustion chamber, okay? Now, chainsaws don't do that. And they have this crazy angle plug. It fires toward the exhaust, right? Okay. Now I want you to really pay attention to this one. I'm going to bore a hole right here in the top. Straight down through. I'm going to build an insert that covers this combustion chamber. It's going to be threaded for a spark plug right here in the center. The insert is going to have a post onto it that's threaded on the outside. This is going to be threaded on the outside, screwed on, and locked. Then your spark plug's going straight down. We won't use this hole anymore. We'll block that. Okay, so now, without having to cut a cylinder apart and make a head, which I've been wanting to do it, but I said this is better, I can tailor this. And if I don't like where I'm at, I can change it for more compression or less. Most saws are around 175 pounds. What if we had so much compression you couldn't pull it over? What do you do then?
Why would you want that?
All right, here's what I'm going to do with that. I'm going to put massive compression in this. You're not going to be able to pull it over until you see this one. After the exhaust, which is right there, closes, that's where the piston's going toward the combustion chamber. It starts building compression. Well, if this is too small in this area, it's going to build too much compression, right? Okay, now what's above the piston is a controlled air-fuel mixture. It's controlled.
As the piston goes up, it makes more pressure at any given point.
And what I'm going to do is, I don't have the number yet, but I'll share it with you when I get it. We are going to bore right in here. And we're going to put a plug. And we're going to put a quarter, 5/16, maybe even bigger, but quarter or 5/16 plug in there. And we're going to use a piece of line. We're going to use tubing. And we are going to get that to come in this angle right here behind that intake boot. It's going to come in right in this area.
So you scavenge some compression.
Okay.
Blow it down into the crank when the window opens.
Yep. Now what that's going to do, when I put that pressure, I'm blowing that straight toward that crank. Now, I'm talking a number, I'm going to say 100 pounds.
Yeah, that's what I think it's going to be too.
I think it's going to be 100 pounds. That's a lot, right? But we have not a big volume. It is nowhere near the volume as the intake of the cylinder. What that's going to do, that's going to have a Venturi effect also. Because of pressurizing that bottom of that case in this manner, I am going to suck volumes more air and fuel. A supercharger pulls air through the carburetor, compresses it, and shoves it into the intake. We're doing the same thing.
So if you got your crank shaped and it's already making air flow in one direction, and now you start shoving more air fuel mixture into there, then that's going to compound that effect, wouldn't it? And make it real nice.
That's exactly right, Cole. I'm glad you brought that up. He ain't no dummy, is he?
Sometimes.
But yeah, I was talking with him. This is not a new project. This has been worked out for quite a long time. I just haven't dared to do it. Now we're doing it. And Buck and Billy's going to get it. And like I said, we'll share the failures too. So, that being said, we're not going to have just 2-3 pounds of pressure in that going up them transfers. We're probably going to end up with about 20 pounds going up them transfers.
That's a lot.
That's massive. That's good pressure. We can tailor that to the position, the height, and the diameter. And obviously it's going to go in at this angle, so it's going to have the Venturi effect. It's going to suck air fuel at a massive rate.
So when you move it here, it's going to have less pressure before the piston blocks that port off that we're going to make.
But more on top.
And you move it up, you're going to have more because it's compressing it more, and it'll can bleed out. So we can control how much pressure and timing we can get just by moving this up or down where we want it to.
That's right.
And that's one of those things you got to kind of work with it and figure out how much is too much, or is there such thing as too much?
Okay, so we've built a supercharger of sorts out of the crankshaft. Yeah, I know what you're going to ask. Are we going to have to balance that? I'm not going to balance the first one. I'll tell you why, because I got to figure I'll blow a couple of these up before I get it right. But my machine shop guy says we can split that crank, we can add metal, we can balance this. Now, what we're going to do, we've used pop-up pistons, all kinds of stuff for a while. We're going to use a flat top. Flat top has more flow than a domed or pop-up piston, and it's lighter. We're going to be able to trim on our skirts, especially the intake side, which I'm leery about because we're moving the cylinder back. We're going to be able to put a big-ass carb on this.
You're going to have to put a big-ass carb on it.
We might put 2 of them. Boy, wouldn't that be fun to have 2 carburetors?
Double pumper.
I think that'd be probably a little bit much trying to. I wouldn't want to adjust it very often if it had that tendency. But I thought that much so far I'll share with you. If you have questions or answers, you guys are smart. Let me turn this camera up so I can
We're not
talk
even going
to
to
you.
get into the afterburner theory.
Oh, yeah.
That's a whole nother thing.
Yeah, you don't know.
It's possible.
You don't know.
You can actually create thrust with this.
Yeah, we can. We already know how. Yeah, we can. We can pull more air.
Why would we? I don't know why, but because, why not? That's why we say
We
why
might
not.
become more efficient with a 2-stroke. We might have a clean burn one if we wanted to try very hard.
We might start where you can get making water. That's when you know you're really clean burning.
Yeah, that's right. Okay, now I'm going to have to get a little short on this. But where we're at now, we know that we can do a center plug design, massively raise the compression. Now this goes back to where does my exhaust blowdown start? The lower the number, that means the quicker it opens, the higher the thing revs. I stop at 96. I don't go no further on a 70cc solid, and that's almost ridiculous. I'll run probably 90 because we're pulling huge compression numbers and we're forcing more air and fuel up on top of that piston. Volumetric efficiency matters. That's what I got to say about that. I hope that once we get these saws done, I don't have a lot left, we're going to start, I'll probably tinker on a Sunday afternoon or something on this little thing, because it's going to be a great deal of work, but it's worth it, and you're going to see it on Buckin's channel. I hope you guys like this video. This is the what if video. You tell me what you think. You're some smart guys out there. I bet some of you guys got some good answers to solving problems you know we're going to come into. Okay, thank you. Goodbye.